Okay, I'll let you pause this and read this. We have section 4.4, question E43 about finger tapping. I'm not sure if, I always thought chocolate contained caffeine. This is saying chocolate contains theobromine, which is similar to caffeine. So that's interesting news to me. And what we have here is a randomized block design. So how do I know that? Well, we have 4 different subjects, and each of these 4 subjects gets 3 treatments: caffeine, theobromine, and a placebo. Placebo, again, it's a sugar pill, basically. There's nothing really in it. Although in this case, they probably wouldn't even use sugar because the sugar may have some kind of stimulant effects also. So probably nothing of effect in this placebo pill. But the 4 subjects, each of them get all 3 of these on different days, 3 different days. So 4 subjects, 3 different days. We actually have 12 specific units that we're looking at in this study. Completely at random would be impractical here if you were going to use each of the subjects multiple days. You wouldn't be able to do that completely at random. The response, the thing that we're measuring, the outcome, is the finger tapping, specifically the finger tapping 2 hours after taking whatever their treatment for that day was. The unit, so instead of being each of the subjects, why isn't it these 4 subjects? Well, because we're giving these 4 subjects 3 different treatments, the unit of response is actually 1 day for 1 subject. Because, say, subject A, the day that she is given caffeine, is going to be a different unit than the day she is given the placebo or the day she's given the theobromine. And that gets us 12 units then, looking at it that way. Treatments, we just have the 3 different medicines. Of course, the placebo is more of a control than a treatment, but you can think of as the control group being just the absence of a specific treatment. And then block is the subject itself. And why are we doing something like this? Again, the point of doing one of these studies is to reduce variability. So variability, as we'll get into a little more later in the course, but it's going to make our results less predictable. If you've looked at the example or the video on the 4 different targets with the bow and arrows, the more variability we have, the more spread out our shots are, the less confident we are at a specific part of our target in that context. So it's going to allow us to find a significant relationship, if there really is one. It's going to allow us to find it more easily if we can reduce that variation. So how does this design do that? Well, if we're taking a specific subject, say I'm a very slow finger tapper. Well, if you only tested me once, say you put me on caffeine, maybe it really does speed me up, but because I'm such a slow finger tapper naturally, we won't really see the effects of caffeine. If you're comparing me to someone who took the placebo but happens to be a very fast finger tapper naturally. However, if you look at me on caffeine, me on theobromine, and me on placebo, then it'll subtract that variability. Yes, I'm a slow finger tapper, and the placebo should show my natural speed. But then the differences between me on caffeine and me on the placebo, or me on the theobromine and me on the placebo, will show up because you're comparing me to me. And the same thing with each of the other 3 subjects. Regardless of what their natural state is, you're going to control for that by testing them in all 3 situations. And then when we analyze the data, which we don't actually do in this section, but the analysis takes that into account. They take each person's baseline, if you will, into account, so that they're really just looking directly more at the effects or the correlation, at least, with these treatments.